Today we're going to take a look at negative exponents and dividing polynomials. I want to recall you back to when you learned to work with fractions. You learned to multiply fractions. One way to multiply fractions is to just go straight across. 3 times 2 is 6, 5 times 3 is 15. But at that point, you need to ask yourself, is that fraction simplified? Sometimes we call that reducing. Is the fraction reduced to simplest form? Is it in simplest form? And the answer is no. And that's because 6 and 15 are both divisible by 3. To simplify this fraction then, we would divide both the numerator and denominator by 3. That's the common factor. They're both divisible by 3. And I get 2. 6 divided by 3 is 2. 15 divided by 3 is 5. And the answer is 2/5. Now to avoid this second step, I want to point out that we can cancel right off. You have to have multiplication. This is when multiplying. As long as you have a common factor in the numerator and denominator, you can cancel those things out. Sometimes teachers might call that cross-canceling, but that's really a bad way to think of it because they don't have to be diagonal. Yes, they often are. What has to happen is you have to have a common factor in the numerator and denominator. Both of 3 and 3 are divisible by 3. Divide by 3, you get 1. Divide by 3, you get 1. Those become 1s. 1 times 2 is 2, and 5 times 1 is 5. So there's our answer, 2/5. This canceling thing becomes very important because, like in the second example right here, if I took 18 times 7, it's 126. And if I took 25 times 12, it's 300. Reducing this fraction is not easy. It's not easy to see what 126 and 300, what factor they have in common. It's much easier right here. Again, we're looking for a common factor in the numerator and denominator. And yes, they're often diagonal. Notice that 18 and 12 are both divisible by 6. Above and below, that's the rule. You must have something above, something below. You must have multiplication. These are both divisible by 6. 18 divided by 6 is 3. 12 divided by 6 is 2. Now look for any other common factors. 7 and 25 don't have a common factor. 25 and 3 don't have a common factor. And 7 and 2 don't have a common factor. This is going to be then 3 times 7, which is 21, over 25 times 2, which is 50. We don't want to work with that. And this last example, again, brings up the idea we're thinking this as cross-canceling is a bad idea. Cross-canceling, no, it's just canceling. You need to be multiplying, and you need a common factor above and below. In this case, what we're really doing is just simplifying 24 over 30. We're reducing that fraction, putting it in simplest form. Common factor above and below, they don't need to be diagonal. It's just canceling. Divide by 6 is the greatest common factor, I believe. 6 is the greatest number that divides into 24 and 30. 24 divided by 6 is 4, and 30 divided by 6 is 5. Now I can just multiply. 4 times 7, well, that's 28. And 5 times 11 is 55. And as long as you've divided all the common factors out, you can be confident that your answer is simplified in simplest form. Let's apply what we just learned with variables. What if I had x to the 5th divided by x squared? X to the 5th, remember, is x times x times x 5 times, and x squared is x times x. Remember how we canceled out the common factors? They have a common factor of x. X divided by x is 1. I'm dividing both of these by x, they're gone. They become 1s though. X divided by x is 1. I'm left with 3 of those. That's x cubed. In the example below, I have x to the 6. There are 6 of them. And below there are 3. And anything divided by itself is 1. So 3 of them cancel. And I'm left with 3 of those things. Now what I'm hoping you're noticing is here we canceled 2 x's from 5 and had 3 left. And here we canceled 3 x's from 6 and had 3 left. And you might be guessing at this point, couldn't we just subtract the exponents? 5 minus 2 is 3, yes. 6 minus 3 is also 3. Yes, that works. And that kind of makes sense if you think about it. Remember how when you multiply, you add your exponents? When you divide, you subtract them. However, we run into a little issue here. Notice that this would be x to the 4 minus 6, which is x to the negative second. And yes, this is correct. X to the negative second is the answer. I will tell you this, we don't usually leave negative powers in our answer. What's going on here? Let's go to what we did on the other page. Look at this. Remember how there were 4 x's above and there were 6 below, and we canceled. They had 4 in common. We canceled and we canceled and we canceled and we canceled. Now students always want to take these 2 that are left and put them up top, but that doesn't work. Remember that when we cancel, go back to the very first page we started, anything divided by itself is 1. These all become 1s. And up above, I have 1 times 1 times 1 times 1, which is 1. And down below, I have x times 1 times 1 times 1 times 1, which is 1x squared. And this is kind of a clue as to what's going on. Turns out that x to the negative second is in fact 1 over x squared. Well, that's weird. Let's take a look at what a calculator says about negative powers. This is from Desmos, the graphing calculator. I went to Desmos and punched these in. 2 cubed is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. There's our 8. That's good. 2 to the negative third is 1 over 8. Take a look again at that previous page. This is in fact 1 over 2 to the third, which is 1 over 2 times 2 times 2. And yes, that is 1 over 8. 5 to the second, that's 5 times 5. That's 25. And 5 to the negative second is 1 over 5 to the second, which is 1 over 5 times 5. And there it is, 1 over 25. That negative power means you take the reciprocal. In the second and third examples, 2 to the negative third was 2 to the negative third over 1. I can always put any number over 1 because anything divided by 1 is itself. And when I took the reciprocal, it became 1 over 2 cubed, which was 1 over 8. 5 to the negative second was 5 to the negative second over 1. And when I took the reciprocal, it became 1 over 5 to the second, which was 1 over 25. And take a look here. Notice how none of these answers are negative. A negative exponent does not mean the number is negative. It means take the reciprocal. For each of these examples then, this is 1 over 4 to the second. Notice the negative power is gone when I take the reciprocal, and that becomes 1 over 16. This is 1 over 2 to the fourth, which is 1 over 2 times 2 times 2 times 2, which is also 1 over 16. 5 to the negative third is 1 over 5 to the third. Notice the negative power is gone. That's 1 over 5 times 5 times 5, which is 125. And x to the negative fourth is 1 over x to the fourth. That negative power means if it's in the numerator, it's going to go to the denominator. If it's in the denominator, it's going to go to the numerator. Remember, the exponent only applies to the number it's on, which I'm referring to this last example. 1 over x to the negative third, then, is x to the third, no more negative power, over 1, which is just x to the third. Anything divided by 1 is itself. X to the negative third over y to the negative second, the negative power only applies to what it's on. The x to the negative third would go to the denominator and become x to the third, and y to the negative second would go to the numerator and become y to the second. And in this last one, this is where students mess up a lot. The exponent on the 3 would be a 1. The negative 5 has no effect on that 3. And below the 8, the exponent would be 1. There is no exponent, there's a 1. That negative 3 power has no effect on the 8. In other words, the 3 and the 8 will not move positions. The y to the negative fifth will. It will become y to the fifth. That's a positive power below. And the x to the negative third will become x to the third above. 3x to the third over 8y to the fifth, then is the simplified answer. Usually we eliminate those negatives and have positive exponents in our answers. A few more examples before we get to the assignment, and this is the way I would look at it. If you want, you can go x to the 5 minus 7 and say that that's x to the negative second, because it is correct, but we don't leave that negative in our answer. This would be 1 over x squared. The way I would do this is, let's forget this. I would just cancel. If you cancel 5 x's here and 5 here, they both have 5 of those x's in common. Remember, it's x times x times x times x 5 times. I'm canceling 5 x's from each. But when you cancel, remember that there's always a 1 left if there's nothing left. Anything divided by itself is 1. If I cancel 5 from each, x to the 7th becomes x to the second, and my answer, yes, is 1 over x to the second. Apply that to this next one. Divide out the common factors. 12 and 18 are both divisible by 6. Divide by 6, you get 2. Divide by 6, you get 3. Both a cubed and a have an a in common, a single a. I'll cancel 1 here and 1 here. There were 3 above, so there's some left above. There are going to be 2 left. Look at the b's. B to the 4th and b to the 7th. The lower number is what they have in common. They both have 4 b's multiplied in common. Cancel out 4 b's here and 4 b's here, but there were 7 below, so there's some left below because there's more below. This becomes b to the third if I cancel 4 from each. This is a 1, but 1 times anything, it has no effect. 1 times 10 is 10. I'm left above then with 2a squared, and I'm left below with 3b cubed. Last two examples. 42 and 56, divide out the common factors. They're both divisible by 7. Divide by 7, you get 6. Divide by 7, you get 8. X to the 5th and x to the 7th. They have 5 x's in common. I'll cancel 5 here. They're all gone. And 5 here. There's 2 left because there were 7 below. They're left below. Y squared and y cubed. They have y squared in common. Divide out y squared and divide out y squared. When I cancel 2 y's from each, there's going to be a y to the first here left. That's just y. Above then, I have 6. Below, I have 8x squared y. 72 and 64 are divisible by 8. Divide by 8, you get 9. Divide by 8, you get 8. A squared and a to the 5th have 2 a's in common. Cancel 2 a's and 2 a's from each. There were 5 above, so there's some left above. That's a cubed. 3 left. There's a b above and a b to the 4th below. They have a single b in common. I'll cancel a b here and a b here. There were 4 below, so there's some left below. There are 3. And c squared divided by c squared, anything divided by itself is 1. These become 1s, but that 1 has no effect because 1 times 10 is 10. It doesn't affect anything. I'm left with 9a cubed above and below 8b cubed. The rest of this video is questions from your assignment. Question 1, we're going to start with some negative exponents here. They give you an example of what's going on. That negative power means reciprocal. Notice the negative goes away when you put it below or when you change positions. In the second one, the negative is below, and when I move it to the top, it just becomes x to the power of n. The negative power is gone. Means reciprocal. Change the positions. Move it from the denominator to the numerator or numerator to denominator and drop the negative. Only move the negatives. Y to the negative p is 1 over y to the power of p. 8z to the negative 13, you need to understand the negative 13 power has no effect on the 8. The 8 would be to the first power. That's the exponent on the 8, and it's a positive one. It does not move. This is over 1. The 8 stays up top where it was. The z to the negative 13th goes below and becomes z to the 13th. The negative power is gone. And this is our answer for the second one. Take a look at the fraction raised to a negative exponent rule. Notice that the fraction gets flipped, reciprocal, and then the power is now positive. So 3/5 to the negative second is actually 5/3 to the second. And we're going to square them both. 5 times 5 is 25, and 3 times 3 is 9. And there's our answer, 25/9. For the last one, x squared over 7 to the negative third becomes 7 over x squared to the third. 7 to the third, time for a calculator. 7 times 7 times 7 is 343. 343 over x squared cubed. This is the power to a power rule. When you have an exponent on an exponent, you multiply your exponents. That's x to the 6th. Many of these questions are very fast. This is a great example. 4 to the negative second is 1 over 4 to the second. That's 1 over 16. 2 to the negative fifth is 1 over 2 to the fifth. Reminder, this starts off as being over 1, and when you flip it, it's 1 over 2 to the fifth. 2 to the fifth is 2 times 2 times 2, 5 times. That's 32. 10 to the negative fourth over 1 becomes 1 over 10 to the fourth, which is 10 times 10 times 10, 4 times. That's a 1 with 4 zeros, which is 10,000. 1 over 10,000. Let's point out that 10 to the first power is 10. 10 to the second power, 10 times 10 is 100. 10 to the third power is 10 times 10 times 10. It's 1,000. 10 to the fourth power we just did was 10,000, a 1 with 4 zeros, right? 10 to the 0th power, there's a pattern here. 10 to the 0th power, anything to the 0th power turns out to be 1. Look at that pattern. 10 to the negative first is 1 over 10 to the first. That's 1 over 10. 10 to the negative second is 1 over 10 squared, which is 1 over 100. 10 to the negative third is 1 over 10 to the third, which is 1 over 1,000. And take a look at the decimal. 1/10 is 0.1. 1/100th is 0.01. And 1/1000th is 0.001. Remember, that's tenths, hundredths, thousandths. That's 1/1000th. And you can see the pattern as you go up and down. That negative power means reciprocal. 1 over 5 to the negative third becomes 5 to the third over 1. And 5 to the third is 5 times 5 times 5. That's a 125, not 15. 125 is my answer. In question 7, 5 to the negative first would become 1 over 5 to the first. That's anything the first power is itself. That's 1/5. 6 to the negative second is 1 over 6 to the second. 1 over 6 squared, which is 1 over 36, 6 times 6. And 3 to the negative third is 1 over 3 to the third, which is 1 over 3 times 3 times 3, 1 over 27. C to the negative fifth, this is over 1, becomes 1 over c to the fifth. One over b to the negative ninth becomes b to the ninth over 1. That's b to the ninth. Remember how when you multiply, you add your powers. For example, x squared times x cubed, that is in fact x to the fifth. If I ask you to multiply x to the negative seventh times x to the negative first, the same rule applies. Negative 7 plus negative 1 is negative 8. We're going to leave no negative exponents. This is 1 over x to the 8th. Question 14. No more negative powers, although you could do these with negative powers, but I'm just going to cancel. In this case, you wouldn't have a negative power. You can cancel 3 e's from each. This becomes a 1 because they're all gone. When I cancel 3 e's above, I have e to the 6. I have 6 left. This is e to the 6 over 1, which is e to the 6th. In question 15, you could use negative exponents. Not my recommendation. This would be d to the 9 minus 12, which is d to the negative third. And then you have to remember, we're not putting negative exponents in our answer. This is 1 over d to the third. My recommendation, though, is to do it this way. Cancel 9 d's above and 9 d's below, but there were 12 below, so there are 3 left. When you cancel, things become 1. Since all 9 canceled above, there's a 1 left. You can't just move that thing up top. Don't do that. It's 1 over d cubed. In question 16, you could say v to the first divided by v to the 12th is v to the 1 minus 12, which is v to the negative 11, which is 1 over v to the 11th. My preference, though, would be to cancel. Cancel a single v above, a single v below. When I cancel, things become 1s because anything divided by itself is 1. I'm dividing a v out of each. There's a 1 left here, and below there'll be 11 left if I cancel 1. 1 over v to the 11th. Question 18, you could do with negative exponents, but to me that makes it more confusing. Just cancel. Look at the a's. There's 4 above and a 10 below multiplied. 4 a's are going to cancel from each. There were 10 below. That means when you cancel 4, there are going to be 6 left. Look at the b's. There are 8 below and 14 above. They have 8 in common. I cancel 8 here. They're all gone. Becomes a 1. 8 here. there are 6 b's left above, because there were 14 above. When I cancel 8 of them, there are 6 left. Cancels 6 c's from each. This becomes 1, and c to the 13th becomes c to the 7th. My answer then is b to the 6th, c to the 7th, over a to the 6th. Question 19. Cancel 9 a's above, 10 below. Cancel 9 from each. When I cancel 9 below, there's going to be 1 left below, a to the 1st, which is a. 3 b's below, 14 above. They have 3 in common. Cancel 3 from each. There were 14 above. That means there's going to be 11 left above. The c's, we have 8 above and 13 below. They have 8 in common. I'll cancel 8 from each. These become 1s, but I don't need to put that. When I cancel 8 below, there are 5 left. And my answer is b to the 11th over ac to the 5th. In question 21, we finally get some coefficients above and below, some numbers. We divide out the common factors. Both 44 and 110 are divisible by 11. Divide by 11, you get 4. Divide by 11, you get 10. Oh, 4 and 10 are still divisible by 2. Divide by 2, you get 2. Divide by 2, you get 5. I'm going to have a 2 here in the top of my answer and a 5 below. If that canceling thing is difficult for you, there are ways around that. A lot of calculators can simplify fractions. Desmos.com can do that. Type in 44 divided by 110. It will give you a decimal, but if you hit this little fraction button right here, it will give you the reduced fraction, 2/5, and that's what I got. See the 2 and the 5? Let's cancel our variables. 5 a's from each. They have 5 in common. They're 11 below. They're going to be 6 below. 8 and 12, I'll cancel 8 from each. There were 12 below. When I cancel 8 from each, there are going to be 4 left below. C cubed and c to the 4th, they have 3 in common, the smaller number. Cancel 3 from each. C to the 4th will have 1 left. C to the 1st, and c to the 1st is c. My answer then is 2c over 5, a to the 6th, b to the 4th. And our last example, 45 and 55 are both divisible by 5. That's the common factor. Divide by 5, you get 11. Divide by 5, you get 9. Cancel 2 a's from each. A to the 12th will have 10 left. Cancel 5 b's from each. B to the 11th will have 6 left. Cancel 3 c's from each. And c to the 4th will have a single c left. C to the 1st, which is c. The answer then is 9, a to the 10th, b to the 6th, c over 11.